Learning with the Illuminati. Part 14. Introduction to the Gustatory System. The chemosensory systems in mammals consists of the gustatory system, or taste, the main olfactory system, abbreviated MOE, the accessory olfactory system, such as pheromones, abbreviated VNO, and trigeminal chemoreception on face, such as irritants. The gustatory system. Humans have about 4,000 taste buds, with between 30 and 100 taste receptor cells on each bud, and these cells have a lifespan of about 2 weeks. However, these are not neurons. The 5 basic tastes these receptors can register are sour, bitter, salty, sweet, and umami, also known as MSG. The taste receptor cells can be divided into 3 types. The first one consists of ion channels for sodium, also known as epithelial sodium channels, or ENaC, and may also be referred to as amiloride-sensitive sodium channels. The second one consists of GPCR, for the tastes bitter, sweet, and umami. The third one consists of ion channels for protons. Taste buds, from the anterior 2/3 of the tongue, signals via the cranial nerve 7, whereas those on the posterior 1/3 of the tongue, via the cranial nerve 9. Taste buds on the epiglottis signals via cranial nerve 10. Further, these neurons synapses in the solitary nucleus in the brainstem, where some continue to the ventral posteromedial nucleus of the thalamus and continue to the gustatory cortex in the insula and the frontal operculum, whereas other go directly to the hypothalamus or the amygdala. Besides the 5 basic modalities, some additional are heat, or pepper, through the transient receptor potential cation channel subfamily 5, member 1. Abbreviated, TRPV1, and is also known as the capsaicin receptor and the vanilloid receptor. Cold, or menthol, via the transient receptor potential cation channel subfamily M. Member 8, abbreviated, TRPM8. Metallic. However, the mechanism for this believed sensation is not fully understood. Some bitter metals like potassium and magnesium may work through potassium channels, and the last possible additional modality are fat. That could work through GPR 120 and CD36. The GPCR for sweet and umami both share the T1R3 subunit of the GPCR heterodimer, consisting of TAS1R2 and TAS1R3. The TAS1R2 portion is believed to respond to natural sweeteners, whereas the TAS1R3 to artificial sweeteners. However, the TAS1R2 gene is inadequate in cats and related animals. These animals may thus be unable to taste the sensation of sweetness. Similar deficiencies or extensions, for receptor genes, varies both between animal species, but also in some degrees between humans. Further, the receptor TRPV1, or VR1, can be activated by temperatures above 43 degrees Celsius, and the TRPV2 or VRL1, by temperatures above 52 degrees Celsius. The TRPV3, in between temperatures of 22 to 40 degrees Celsius, and the TRPM8, or CMR1, below 22 degrees Celsius. The TRPV1 do also exist on primary afferent nociceptive neurons like the C fibers. The TRPA1 receptor reacts to noxious and inflammatory irritants such as mustard and wasabi, however, can also be activated by low temperatures. And lastly, the Synsepalum dulcificum, also known as the miracle fruit, due to its active component miraculin, is believed to make the sweet receptor responsive to acids, thus making sour food taste sweet, for about an hour.